Hey everyone, in this video, I'm going to talk about the next steps for this air design class, which is basically familiarizing ourselves with the flight simulator, especially how we can model the airplane in the simulator and what are the parameters that we need to acquire. The goals of this exercise is for us to upload an aircraft model in the simulator using the Excalibur 3 software. And doing so, we'll get to see what are all the different parameters we need to like model an airplane in the sim. And that'll give you an idea of how detailed the aircraft that you're going to design need to be so that you can successfully upload your model into the sim and have and have you fly it and also have the test pilots come in and fly and give you feedback as well. All right. So the first part of this homework, basically, first part of this project or this this assignment, basically deals with you finding the data that you need to model the aircraft in the sim, and then in the next week we will look into scheduling time in the simulator so that you can upload the model in the sim and see how it flies, etc. All right. So the goal of this exercise is also for you to use this is like this freeware softwares like Plot Digitizer, XFLR5 to obtain geometry and some aerodynamic details, right? There are some instances where you cannot find the, like, say, for example, the size of the tail, because most likely the data that you will get is, basically talks about the wing size and the wing area, but rarely the specifications talk about the tail size. Well, if you want to find that, then you're going to have to rely on plot digitizer, right? So you find the span, you find the core, you find the area. And then XFLR5 is, if you find out what type of airfoil it is using, then you can create the CLCDCM for that airfoil at a particular Reynolds number, and you can input that into the simulator model as well. All right. So that's basically the goals. Um, Now, I'm not sure how many of you know about the capabilities of our flight simulator. Our flight simulator can model aircraft attitude and performance using physics. Again, it's not quite a video game, even though it looked like it. It flies based on physics. It doesn't fly if the design doesn't fly. It is simple as that. And the simulator actually rests on top of a Stewart platform, which mimics aircraft's acceleration, not aircraft attitude, because the main point is that when you sit inside the cockpit right here, close close this door, and then you turn the motion on, right? What you really feel is the acceleration, and the simulator tries to mimic those acceleration by finding those acceleration quantities in the from the equations of motion, right? And that's how the simulator basically mimics those acceleration, right? It doesn't necessarily mimic the attitude, but it mimics the acceleration, right? So it has all the stick and rudder inputs and the trim inputs that you need, to basically fly an airplane. In fact, if you see here, you have a collective as well, so that you can actually fly a helicopter too. And the neat thing is you can program, the control surfaces to basically deploy any, or you can program the inputs, the control inputs to deploy any type of control surfaces that you want. Right. And one of the neat thing about the sim is also you can actually download the performance metrics, like, attitude, velocity, acceleration, GPS coordinates and all of that. So in real time, you can download those data, from the simulator software, which is, I think, is pretty cool. And now, as you will see in this week's module, you can also use a standalone.exe where you can install in your computer and upload the model in that software, and then use the software to generate a model file. And we will take that model file and upload it in the sim and actually fly your design, right? And also, thanks to the TAs and one of our grad students, that we can actually connect or hook up the monitors um, of the simulator, to a standalone computer, and you guys can access it through Zoom, just in case if you're not comfortable coming to campus and operating the sim, right? So we can fly it for you. All you have to do is just log into Zoom and basically watch how your aircraft flies, and then we'll give you feedback on what you need to change, things like that. All right. So it's a pretty unique software, pretty unique hardware and software. So moving on, like there are the faculty in our department actually got a recent grant. Um, it's a pretty big grant, and what we're gonna do is we're gonna replace this stick input, the stick like control stick, with a force feedback stick, which means that you can actually feel the forces of the aircraft on the stick, which is, I think, again, it's pretty cool. All right. So, okay, it's one of a kind simulator. I think I'm so excited for you guys to start using this. I know some of you have already started using this, but those of you who have not experienced this it's a pretty unique and a very cool tool for us to use. All right. So, before we move on, I would ask you guys to click this link and download the model editor software and the model file from the link. Again, keep in mind this software is a .exe, so it can only be installed on a Windows software. If you have a Mac, you either need a bootcamp or Parallels to run this software. All right. So again, this is just so that if you don't like to be on like in the simulator while uploading all the data, you can do all the data upload in your computer and then just send us the model file, and that we can upload that model file in the sim and then fly it. All right. So that's again, that's very important. So moving on, like you have to select a model, an aircraft model, or aircraft to model in the sim, right? But before that, you have to find a partner to work with. Make sure, like after the end of the first homework, the performance homework, I hope you were able to identify somebody that you can work with throughout the rest of the semester. Mainly because we move on to more time-consuming parts of the design process. You really need somebody that to share the workload with. Otherwise, it's just too much, right? So, and the aircraft that you're going to choose to model in the sim in this homework doesn't have to be the class type category of the airplane that you want to design. What I recommend is that you select an airplane where the specs and parameters are relatively easier to find. Again, you still have to rely on plot digitizer and XFLR5 to back out some of the geometric and aero specs, but you cannot just stay away from like high performance aircraft, or you know again, don't do anything esoteric, because it'll make your life a lot more difficult, because some of the performance metric, or not even some of the specifications of high performance airplane may be classified, and you can't get that. It'll make your life a lot more difficult, right? So what I recommend is any general aviation aircraft, which is good, but stay away from Cessna 142 and 172. Again, this is a requirement. You can't select these two airplanes, because these two aircraft has been modeled pretty in detail in E3, and that in fact the example file that you will download along with the software belongs to the 152 172 model. All right. So anything except 172, 152, just select any general aviation aircraft different than those. You can also select a light sport aircraft, a single engine trainer, or light commercial aircraft. All right. So it doesn't really matter what aircraft that you're choosing among this category. The workload is gonna be the same. So don't think like general aviation or light sport will make your life easier, right? So I mean, all of these have like it's on the same similar like workload. It'll take similar workload to find data for all of these. All right. But the main thing is, once you selected an airplane, you really have to run it by me for approval. This is just so that I know that you're not digging yourself too deep into the project, and the goal is for you to find the data within a week, and then in the next week, you're gonna have to upload those data in the sim, and basically fly it, or make it fly. All right, so that's the goal behind this project. All right, so here are the different data collection categories that you have to worry about. So CG and mass, for an aircraft that you choose, you have to look up uh, some information about the mass and the CG. You're gonna have to look some information about the fuselage, about the engines, and the landing gears. Most of these are like geometry related, and the propulsion, like engine especially, has some performance metrics in it, and you should be able to find that pretty easily. So you will be modeling the wing and the horizontal tail and the vertical tail using these H panels. and V panels, which I'm going to talk about in the next video. And then, the H panels and V panels will actually have, you'll also you'll be inputting the elevator, rudder, aileron, flaps, all the control surfaces you have. It's kind of basically will go in here, and the control mappings is where you choose, what type of control surface you have on each of the panels, right? So I'll talk about that in detail in the next video. You don't have to really worry about systems and tuning, because that is when we get to fly the aircraft, that's when we had to tune some of those parameters to make it actually fly better. All right, so that's pretty much it. In the next video, I'm going to talk about the different parameters that you have to collect for these different tabs. And I'm going to tell you how you can model the wing and the horizontal tail using this, in this section of V panels. All right, so I'll see you in the next video.